now that we've finished our review, we can finally start on our actual free response practice. So for the 2014 number 6, it says, consider the differential equation dy dx equals 3 minus y times cosine x. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 0 equals 1. The function f is defined for all real numbers. Okay, for a portion of the slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. So here's the graph that they give you. And they want you to sketch a curve that passes through the point 0, 1. And 0, 1 is right here. So all you have to do for that, when you're sketching a curve on a slope field, is follow the lines. So 0, 1 is right here. And if you follow the slope lines, you will get this. And as you can see, it passes through the point 0, 1. And that's all you had to do for A. Next, for part B, you want to write an equation for the line tangent to the solution curve in part A at point 0, 1. Use the equation to approximate f of 0.2. So what you're looking for is a tangent line at the point 0, 1. So the line equation is y minus y1 equals m times x minus x1. So what you would want to do first is find the slope, and since they already give you the slope formula, the differential equation, you have dy dx equals 3 minus y cosine x. All you have to do to find the slope is plug in 0, 1. So our slope at 0, 1 is 3 minus 1 times the cosine of 0. And that equals to be 2 times the cosine of 0 is 1. So 2, and your slope is 2. So you have all the parts you would need for your line equation. y1 is 1. We found our slope just now. x1 is 0. And all you have to do is plug in your numbers. Y minus 1 equals 2 times x minus 0. So that would be y minus 1 equals 2x, and you could add 1 to both sides to isolate 1. So y equals 2x plus 1. And that would be your tangent line equation. And then for the second part of the problem, you want to approximate f of 0.2, and all you would have to do is plug in 0.2 to this equation. So y equals 2 times 0.2, which is your mu x, plus 1. So you would get 0.2 times 2 is 0.4 plus 1, and that's just 1.4. and that is the approximation of 0.2. And the last part to our 2014 Fourier response practice is part C. Find y equals f of x, the particular solution to the differential equation with the initial condition of f of 0 equals 1. So we were given the equation dy dx equals 3 minus y times cosine x. And it wants us to find the particular solution to the differential equation. So the first thing you would have to do is separate the things with the x's and the things with the y. So dy over 3 minus y equals cosine of x dx. And then after you do that, you can find the integral, integrate both sides. To make this integral easier, you can plug in the bottom into a u. Substitution. So you would have -1 in the integral of du over u equals the integral of cosine of x dx. And if you look at this, this is just the natural log. So it's negative natural log of u plus c equals the integral of cosine x is sine x plus c, and we don't really want u there, so we can just substitute the u back into there. So negative natural log of 3 minus y plus c equals sine of x plus c. You could subtract c on both sides and we'll still have a constant on that side. So negative natural log 3 minus y equals sine of x plus c. We could also divide both sides by -1 so that this one doesn't have that negative sign. So you would get natural log 3 minus y equals the negative sine x plus c, because it's still just a constant. Then, so that to isolate your y, you would do the multiply this by e, multiply this side also by e, so that you can cancel the natural log. So on this side you would only have 3 minus y equals, and then e to the negative sine x times e to the c, but e to the c is just still a constant. So you would have 3 minus y equals c e to the negative sine x we know that the initial condition is at f of 0 equals 1, so we can plug that in so that we can find c. So 3 minus 1 equals c e to the negative sine of 0. Sine of 0 is just 0, and e to the 0 is 1. So c equals 2, and then we plug that back into the equation we had. So 3 minus y equals 2 e to the negative sine of x. And then we could isolate y by adding y to both sides and then subtracting 2e to the negative sine x to both sides. So you would get y equals 3 minus 2e to the negative sine x. And that would be your solution.